Good afternoon. Good afternoon. Today I would like to discuss with you one of the thing which is quite important for us, in my opinion, as we are surrounded by batteries every day. We have this kind of device always with us. In our houses, we are working with them, we are traveling with them, we are also traveling inside this kind of devices like electrical vehicles. Vehicles are one of the biggest devices which are battery powered, and the capacity of this battery is quite sometimes very big. So to understand the importance of this aspect, I will discuss with you, I will show you how big the market of this kind of devices is in the world. I will try to as well describe you in the short way what the fire of the battery means, how it starts, what are the risks involved with this fire. I will try to also describe you the testing of this kind of devices. And one of the most common myths related to the electrical vehicles as well. Luckily, we have several things which we can do to protect ourselves. So we are living in the world where we have a lot of devices which are battery powered. We have the wearables, we have laptops, cell phones, tools, electrical bolts. A few months ago, when I was in the hospital several days, I had also a bed which involves battery inside. Being in the airport, I saw the cabin luggage which turns into the e-scooter, where the person was traveling across the airport on it. So the amount of these kind of devices is significantly in our life. So we should know the risk which are associated with this kind of devices. The most common risk are electrical shocks, overheating, fire, explosions sometimes, and toxic gases coming out from these devices. However, it's not like that all battery will explode. It's in the several specific circumstances, so we don't need to be afraid. I don't want to contribute with fire mongering, so we don't need to be afraid. We just need to understand what are the risks, what we can do to avoid the risk, and how we can protect ourselves. To protect ourselves, we should also look on the warning signs coming out from these devices, like the heat, the swelling of the device, the swelling of the batteries, noise coming out from these kind of things, the odor or the smoke, which is the first thing before the fire come out. As I said, the vehicles are the biggest devices which are battery powered. We have the passenger vehicles, we have micro e-mobility, which involves scooters, which involves e-bike or hoverboards. We have trucks and buses, but the most common thing is the passenger. So we can describe four main group of the vehicles, which is the old school vehicles with internal combustion engine from the one side. From the other side is a fully electrical vehicle. Between we have some hybrids, normal hybrids or plug-in hybrids, which is, as you know, the hybrid which can be charged externally. Market growth of the electrical cars is quite significant, and across the last decade it rise significantly. This graph is only purely based on the vehicles. It doesn't include the micro-mobility, because if these, if we will include the e-bikes, e-scooters, or hoverboards, the numbers will be much bigger. There are several forecasts for vehicles which will be at 2030. And depends on the model which we include in our calculations. The numbers are different, but it doesn't change the shape of the graph. The number are huge in 2030, which means the risk might be also much higher. So we should know what are the risks involved with the fire of the battery. Each fire of the battery starts from the same point. We have a term, thermal runaway. Thermal runaway is the process which starts from the abusing of the battery cell. The abusing factor might be different. We have a mechanical factor which is starting from the puncture, impact, or car accidents. We can have a thermal, which is the exposure of the battery for the high temperature. We have the electrical abuse factor, which comes from the overcharging, over discharge as well as short circuits. The thermal runaway is the first point which leads to propagation from the one cell, the adjacent cell, and the whole battery pack. Which means in some circumstances, because of the flammable gases, it may cause explosion. Thermal runaway starts from the trigger, as I described previously. This means the cell which is abused is starting heating up. The heat is transferred to the adjacent batteries, and at this point we are getting the propagation. In this point, we have gassing of the batteries, which release the flammable toxic gases. Plus, we can see sometimes the flames as well. In certain point, from one cell, we have a full battery pack which are at fire. The fire of this battery is it's a different than normal engine, combustion engine, because the battery can fire a long time. The fire of the battery involves also very toxic gases, which means we need to be aware that especially the first responders should wear a proper PPE masks, a full suitable system to protect themselves. To protect surroundings, we should also use a specific things to suppress or extinguish the fire. Unfortunately, the fire of the battery is really hard to suppress, to extinguish. Even if the whole car is sink into the water of the container, the battery can be under fire for the several hours. This is why we have a lot of researchers on the globe just to trying to get knowledge of the process of this kind of fires, how to protect ourselves, how to protect the surroundings. There are people who are saying that we should leave the car, the electrical car, to burn it out. There are people who are saying we should sink the car into the water container. However, even if we are using the water as an agent to suppress the fire, we should know that the water is contagious. We need to take care of this water as it contains a lot of chemicals which has to be removed from the water to make it clean. And doesn't matter which agent we choose, doesn't matter which way we choose to protect the surrounding, to extinguish the fire. We first needs to understand, needs to remember that the most important thing is the safety of the first responders. As car parks, tunnels, we can say they are fairly well prepared for this kind of fires. I mean, of course, the fire doesn't matter the place, it's not a good idea. But comparing the car parks, our living rooms are not the best place to have this kind of fires. So we should remember several things which I will highlight at the end of the presentation, that these energy storage systems, either they are portable or they are stationary, and they are quite big. Even I saw a big building in Europe containing a lot of compartments. Just with this kind of energy storage systems, in the case of the energy breakdown. So what we can do to verify if this kind of battery is fairly well prepared for using it in the vehicles. We have several standards to do the testing of the batteries which are involved in the vehicles. The main, most common use in Europe is resolution 100, but all of them are purely the same. They are, the process is that the battery is exposed to the fire, the pure fire, full fire, and the criteria is only one: the battery cannot explode. There cannot be any projectiles which can damage the surrounding, which can damage the first responders or other people's. So on the basis of the regulation number 100, which is used to the homologation process in Europe, homologation process is like a certification. We have a certification of the doors, walls, ceilings, facades, active and passive systems. The same, we have a certification of the cars or its parts. It is designed to make sure that the car is safe and all its parts are also safe for the users. The battery is subject to very robust tests: mechanical, electrical, thermal cycling, as well as a fire resistance. Fire resistance of the battery is done either on the modules or the full battery pack. And you can see on the screen the basic diagram how this kind of battery test is conducted. We have few minutes total exposure of the fire, involving either screen or without screen, and then there is several hours of observation. It depends on the temperature of the battery, and the criteria is always the same: it cannot be exploded. There cannot be explosion. Any sudden pressure release or any projectiles coming from the whole assembly of the battery. So we can say that it's only 70 seconds plus 60 seconds plus few hours. Few hours is without the fire, just seconds are with the fire. Yes, but the reason behind the seconds is to give information for the first responders that these kind of, during the car accidents where the fuel is under the car and it catches the fire, there will be enough time to evacuate the people from the bus. There will be enough time to give first responders time to protect the surroundings. And this is one of the reasons where we need to test electrical vehicle batteries. It doesn't matter that this is for the vehicle or other rechargeable electrical energy storage system. All of these things has to proceed with the same thing. They need to be subject for the several tests. One of these tests is a fire-resistant test. So the most common myth which is around the globe is the EV car is burning more than normal combustion car. And it doesn't. It burns the same. Doesn't matter from the fuel. The fuel doesn't matter. The fire of the car may turn into the pure inferno. It doesn't matter if it's internal combustion, hybrid, or EV battery car. Each car burns like inferno. This is why we need to remember that if there is a fire in the electrical battery, Usually it's, we can see these on the sides, jet fires. In some places they are called like a mustache because it looks like a mustache. So unfortunately, it's not standardized the place where this kind of mustache can occur, because these fire jets are coming usually from the vent points. The ventilation points can be either designed or it can be done because of the melting of the electrical cables or other penetration services in the casing of the batteries. And as so far, we have no standardization that this kind of vents should be on the left side, should be on the right side, in front or back. So the first responders, the firefighters, never knows from which side these kind of jet fires can occur. And what we can do to protect ourselves. There are several things how to extinguish. We can use the blankets, we can use the water sprinkles or other dry agents. We can sink the water, sink the car, but it depends on the location where the fire occurs. There is a problem. Bigger problem is on the vessels where you have where the fires occur on the ferries, on the street, on the ships. So depending on the location of the fires, depending on the location of the storage of this kind of devices, we should choose appropriate response to the fire. Unfortunately, there is no one solution. The solution is still under testing. There are academic discussions how we should protect the surrounding from the fire of the EV. There is a lot of research now how we should extinguish, with what kind of procedure, how we should act or react. First thing, what we should know is the training of the first responders. Enough training, the good knowledge, what can be done, what can happen during this kind of reaction, that there could be an explosion, that the fire can be really aggressive in some cases, because of the car involves a lot of plastic, a lot of things which, if there is a fire, the fire can rise to inferno. So there is no golden point. What is the best one? Maybe in the future, because the battery technology of the battery is changing. 5 years ago, 10 years ago, there was a different technology than it is now. Chemical of the battery is also different, and it will be different in the next 5-10 years. So once we will get the knowledge, as we have the knowledge from the fires of a normal car or other products, then we will have information how we should react. The technology rise, the technology development is fast. So at this moment, there is no one solution. We need to protect ourselves using different solutions, using different things, but also we need to remember that these should be designed to a proper place where we want to use them. In Europe, there is one building where the owner of the building is asking all people to keep e-bikes or e-scooters in one place. There is a quite big, it's like a parking for the e-bikes. So there is a question how we should protect this parking. Using the same method as for the normal car park or different one. And there are several guidance. These guidance are still under process. There is a lot of institutions who are involved into this guidance to protect ourselves, to give us information how we should react, what we should include in the process of the design of these kind of spaces, what we should not to do, and how this design, with what kind of minimum system should be included. For our personal safety, we should keep in mind that if we have an e-bike, we should not store this e-bike or e-scooter, or we should not charge them on any way of exit, because if there will be a fire. And this is one of the biggest and one of the common issues related to the fire of e-bikes in residential buildings, because of most of the deaths, fatals, happened when because this e-bike, this e-scooter, was blocking the exit. The evacuation process was affected by these devices. So if we want to charge them, we cannot charge and we cannot store them in the way that we will not be able to escape, to leave the compartment. One of the thing which is discussed, and maybe this is not the best way for the owner of these devices like e-scooter or e-bike, is to keep them in the compartments. But also there is a question how to certify this kind of compartments. There is no standard for now. At this moment, there are projects for the standards, how we should test these compartments for the batteries. There are several tests real tests of the batteries inside this kind of compartments. And maybe this will be the future. Maybe the future will be totally different, using the different system of extinguishing. But the risk will be the same. If the battery will be abused, if the battery will catch fire, the risk for the surrounding and for us is quite big. And I would like to highlight once again that the myth that the battery car is burning more than normal car is not true. Car doesn't matter about the fuel, is burning in the same way. Each car can turn into the inferno. Sorry. This myth comes because of it's more clicky. It's media driven. So we should focus on how to react on the real situation, not on the myths.